What we're doing here is we're trying to draw a chart, a height and time chart. Okay, depth of water. So depth, it can be height and then time on this axis here. Okay, let's start with A. When you start pouring a tap into here, what sort of happens? At the bottom, when's that at its widest? When's that at its widest? When is the jar at its widest? Middle. That means the height will be rising at its slowest. Would that make sense? So it sort of starts off fast. Sorry, it starts off really slow because the height isn't. Sorry, it starts off faster, right? So it starts off steep. And then what should happen is when you reach the middle, what happens? It starts to slow down. But after you pass the halfway line, what happens? It starts to go fast. Bit like a, do you know, ever go go-karting or Formula One? Bit like a chicane, isn't it? All right. And then what happens at the very end, though, when we hit here? So it goes, and then it goes propel like that. Does anybody have something like that? It's difficult to do, though, isn't it? I'm finding it difficult, and I'm a teacher, look, and I'm finding it difficult, okay? It's not my first time doing this either. Ernesto, if you want to go more central, you can see the board a lot easier, maybe. Okay. What about the next one? I think it's very similar to the one we just did, isn't it? It's a circle, isn't it? And it's at its widest point here. So it's at its slowest point in the middle. So I think it's going to do the exact same thing. But what happens at the very end? But this is much shorter, isn't it? So what's that mean? Just a little. Everybody cool with that? Did anybody get anything like that? All right, well done. Because they're hard to do. Okay, so you can take down the diagram as we do it. That'd be great. Okay, so that's A and B. So anything that goes on the board goes in your copy if you haven't already got it. That's the default. Okay, Jen, so there's the first two. Okay. You see them now? Okay. Right. What about the next one? C. Does it change shape at the start? See the way the width kept changing in the circles. Does the width stay the same? So what does that mean? A straight line. Same consistency, same rise. Okay? But then what happens at the end? It goes much narrower, doesn't it? So then it accelerates much faster. Okay? So what's that? Height and time. Now the next one's the easiest one. Can anybody tell me why? Why is it a straight line? The width stays the same all the way through it, doesn't it? So when you're filling the water in, it rises at the same rate. So we're just going to go for, there's a nice straight line. Okay, I'm going to pause this now. This is not question 8 I'm doing now, okay? So what we can see on the board is that they all run 10K, don't they? Whoever reaches the 10K line first won the race. So they agree that Adam hits the line first, Barry hits a second, and Carl hits a third. Okay? And they all have different races, don't they? Barry stops for some reason. How do we know Barry stopped? Yeah. Flat line means Barry stopped moving at one point, okay? Now, it's measured in minutes and it's kilometers, okay? So let's figure out what the questions want from us. Who won the race? Anybody? Adam. Okay. Which runner was given a head start? Which runner didn't start at 0-0? Carl. Carl started at 0-1. How much of a lead was he given? A 1 kilometer lead. So that's Carl. Was C or K? C. Which runner had to stop for a rest? Barry. All right, this was handy. Which runners overtook whom and in what order? So, this is the first overtake, is it? So this Adam overtook Carl, and then Barry overtook Carl, and that's it, isn't it? Just 2 overtakes. Okay. Which runners overtook in what order? Yeah, we sort of did that. Calculate the overall average speed for each runner. Okay, so can everybody take out your calculator? Because we're going to do this together. Javelin. So here's what we're going to do. Okay, guys, we're going to do 10 kilometers. What does it want the answer in meters per second or what? Wants it in kilometers per hour? Ouch. All right, let's do it. All right, 10 kilometers. I'll do Adam first. So let's do Adam first, guys. It's 10 divided by what? What's his 55 minutes? So I'm going to do 0, 55. All right, now trust me, in the game a long time. And then the next one, 10 divided by. Oh, he did it in an hour, didn't he? Just, yeah, it was 1. And Carl, we have to estimate Carl, don't we? What did you guys estimate Carl at? 67-ish. Okay, so I do for Carl, I do 10 divided by 1.7. I have him as 67. What do you have it as? Oh, good. Well done. Who said that? Excellent. He didn't do 10 kilometers. He only did 9. That's excellent. Good spot. I would have got that wrong. Okay, put them into your calculator. And so did anybody do 10 divided by 0 dash 55 dash? And what do we get there? 10.9? Yeah. Sorry, that should be red. And the second one? Second one's easy, isn't it? 10 kilometers an hour. And finally, the last one. Who got 9 divided by 1 and a 7? So does everyone know how to do the calculation? Does everyone know the button? If you don't know the button, just call me down. So see my calculator on the board? It has a fact button above it. Yeah. And then you press when you get a fraction answer, you press the SD button. Who got 8.06 kilometers an hour? Now, believe it or not, yeah, I was about to say, I lost marks for that. Every time I lost marks. I got it perfect, but I lost marks. Why? Yeah, I didn't read the question. Everybody paying attention? Okay, so we're going to be doing, that's going to be 11 kilometers an hour. This is going to be 10 kilometers an hour. And the last one's going to be 8 kilometers an hour. Did you do 10 or 9? You did it. Yeah, he only traveled 9, you see. Yeah, yeah. Any questions? You sure? Okay. Now, next one. Okay. Identify the stage where he is traveling at constant speed. Traveling at constant speed means what? Straight lines. So the answer for part 1 could be A or what one? Or what one? It could be A, C, or E, whichever one you want. Okay? Decelerating means... Oh, sorry. No. Oh. Stop a minute. There's a difference here. What is the normal graphs we do? We usually do distance time. What one is this? Speed time. Oh dear. Means that we have to treat it completely differently. Now let me explain. Ready for this? Just listen. Once again, I know what I'm talking about. Okay. What does 0, 0 mean in this question? At 0 seconds, you're going no speed whatsoever. That makes sense? Now, this one here. What's that? 30? 30. Does everyone want to know what that means? 30 seconds in, you're traveling 30 meters per second. For argument's sake, I don't really know what this is. I'm just going to call it 70, if that's okay, just as an estimate. Now, what's 70-30 mean? 70-30. 70 seconds in, you're still traveling 30 meters per hour. How long were you stuck at 30 meters per second? 40 seconds, yeah. Yeah, exactly, right? Now let's go up here then to D. What do we reckon D is? Yeah, 60 meters per second. At 90 seconds in, you're going 60 meters per second. Okay? And what about this one over here? 120 seconds, you're still going 60. Now, then what happens at the very end? 150 seconds in, you stop. How do you identify if you stop or not? What's the key part you're looking for? You're looking for the y-axis to be 0. This is confusing because in the previous questions we were doing, put that way with this. Now, okay. All right, guys. So, all right. When's it traveling at constant speed? I think there's only 2 sections that happens at. Which ones? B and D. Because your speed doesn't change, does it? Starts at 30, ends at 30, starts at 60, ends at 60. So there are the 2 sections. When do you decelerate? You went from 60 down to 0. What does that mean? You got slower, didn't you? Which means you decelerated. So what's that mean? E. Excellent. What about acceleration? When you get faster? A or C, because you're getting faster. At its highest speed. At its highest speed? D. That's where you max out at 60 meters per second, isn't it? You don't go any further. All right? So that'd be D. Let's keep going. What was the object's highest speed? 60 meters per. How did I know it's meters per second? It says it in the blue, doesn't it? So it's not kilometers per hour, it's meters per second, okay? And for how many seconds was the object traveling at its highest speed? Starts at 90, ends at 120, 30 seconds. Okay? For how many meters? Oh, now this is difficult. How many meters was the object traveling at this highest speed? What was the point of this chapter again? D, S, T. Which one are you looking for? Read the question. It says you are looking for for how many meters? That's a distance question, okay? If we can just, now, distance divided by, sorry, it's speed multiplied by time, isn't it? So what's the speed? Speed is 60. How long were you traveling for? So what's 60 multiplied by 30? Yeah, nearly 1,800 meters. Okay. Now, the area under the graph at stage A is the distance traveled for the object in the first 30 seconds. What was the distance traveled by the object in the first 30 seconds? What was the average speed of the object in the first 30 seconds? Okay. Does everybody see what it says? So here's what we're going to do. I'm just going to zoom in here. Okay. And sorry about this. And then I'm going to grab this question here. And there's a lot of writing on the board, isn't there? It's a bit confusing. Here we go. Now, let's dissect the language of the question really good. So, what happened to it? 1 sec. cut, which means I should be able to paste. All right, excellent. Right, ready? So this is the part of the graph we're interested in. Okay. Does anybody remember doing the area of a triangle? So this triangle here. Anybody know how to get the area of a triangle? Half the base by the height. Okay. Can you tell me what the height is? So it starts at 0, it ends at. So what do you think the height is? Okay. And here to here, 0 to 0 to 30. So 30 is the base and 30 is the height. And what do we say? 30 by 30, lads? You'd use your calculator. 900 divided by 2. 450 meters. Is that okay? Now, what's the average speed, though, is what we're trying to figure out. Now, use your distance, speed, time triangle. Which one are you after? If you read the language of the question, you're looking for average speeds, which means you're looking for the S, which means you're going to do distance divided by time. So what is the distance again? 450. And the time? 30 seconds. Then what you get? Anybody? 15 meters per second. All right.